In this video, we will showcase the ability to select edges that you want to weld from a CAD model. We will showcase the toolpath generation from the selected paths, and we will demonstrate how a path programmed by selecting edges in CAD can be superimposed onto a 3D scan. First, we load up element X. Then, in cladding or welding mode, we add the model. Now we select the path. The edges are automatically identified in red. The green edges are the edges that we are selecting to make the path. Now we have the path imported, and we can create the toolpath. We will demonstrate the toolpath briefly for you in the robot simulation software, Robotic. Let's showcase some structural welding now and load in a model that has some structural welding geometry. In path selection, we can select the edges that are identified in red, or we can draw our own path in green. Again, after creating the path, we can use that path to generate an additive toolpath. Here's a quick demonstration of the toolpath in the robot simulation software. Note that the additive toolpath generation takes into account the approach and the geometry of the end of arm tool to avoid collisions with the work. In a moment, we will demonstrate how we can adapt a CAD programmed path onto a part that has been 3D scanned by the robot. What makes this technology invaluable to the structural welding industry is the ability to use 3D scanning on the robot to compensate for bad fit-up or parts that move. This adaptive automation allows us to further labor savings as fewer technical staff are required to operate robotic welding cells that have this technology. It also allows you to move from specialized fixturing to more generalized fixturing and potentially save on some of the storage space required to store all of those fixtures. Here you can see the toolpaths in pink. The blue is a mesh created from the 3D scan of the actual part on the table. The pink is the actual point cloud from the 3D scan of the part. Using element X, we can superimpose the CAD model and the tool paths onto the scan. You can now see that the CAD model in light blue is on top of the dark blue mesh from the 3D scan. Here we are just showing and hiding some layers to show you the toolpath better in pink. You can see that the pink toolpath is very close to the mesh from the 3D scan, which is now gray and in the background. The final step is to take the toolpath we created from the CAD model and project it onto the mesh from the 3D scan. Now you can see that the path has been projected onto the mesh of the 3D scan. From this path, we can generate the toolpath for the robot. Momentarily, you will see a simulation of the robot executing the generated toolpath. All of the steps that you've seen here can be performed in Element X. We have also automated all of these software processes into just a few clicks for welding manufacturers and specific industries. We are also able to take programs that are on the robot and use our software to adapt the toolpaths to 3D scans of the parts. In other words, each and every part is scanned, and the robot toolpath is adapted to each part individually. If you're interested in a robotic work cell that can adapt on the fly to each workpiece, please contact us through our website, automationexperts.ca.